Need in order to be able to do this section is be able to expand the concepts of solving linear equations, understand how to solve linear equations and quadratic equations, and know how to determine if a number is a solution to an equation.
Alright, so let's go ahead and look at a basic example. We have the square root of x equals 5. We are asking the square root of what number is equal to 5? Well, hopefully you guys know that 25, the square root of 25 is equal to 5. And so that is going to be our answer, x equals 25. So now let's see if we can analyze this a little further and see what we did. So how do we get rid of a square root, and how do we get from 5 to 25? And the answer is squaring. If we square a square root, they cancel. And whatever we do, how do we get from 5 to 25? Same thing, we square both sides. So if we square both sides, we can cancel a square root. And that's going to be our basic procedure in order to solve radical equations. Okay, so our procedure in order to solve radical equations. The first thing we want to do is isolate the radical. If you have anything outside of the radical, you want to move it to the other side of the equation. From there, we want to square both sides of the equation to get rid of the square root. And then we finish solving for the variable using either linear or quadratic techniques. Our final step is we want to check our solution. This is required because not every number is going to work in our original equations. If the answer that we come up with does not work in the original equation, we're going to discard it. We refer to it as being extraneous. Alright, so let's go ahead and look at some examples. The first example we have is the square root of 3x plus 4 equals 8. The first thing that I want to do is I notice that there's nothing outside of the square root that needs to be moved. So I'm going to square both sides. On the right side, my square root and my square cancel. I am left with 3x plus 4. 8 squared is 64. From here we have that this is a linear equation. All of my variables are on the left. I need to move all of my constants to the right, so I'm going to subtract 4 from both sides. We get 3x equals 60. Divide both sides by 3, and we get x equals 20. Alright, let's go ahead and check this solution. If we plug in, we get the square root of 3 times 20 plus 4. I want to know, is that equal to 8? 3 times 20 is 60. 60 plus 4 is 64. And now what is the square root of 64? It is in fact 8. And so we do get a true statement. So x equals 20 is our solution. Alright, let's look at example C. Note here, we do have things outside the square root. So the first thing I want to do is isolate my square root. Anything that is outside, I'm going to move to the other side. So we get square root of x equals -1. From here, I can square both sides. On the right, my square root and my square cancel, leaving me with just x. On the right, -1 squared is 1. All right, let's go ahead and check it. If we plug this in, we get the square root of 1. Plus 1, I want to know, is that equal to 0? And the answer is no. Square root of 1 is 1, and 1 plus 1 is 2, which is not equal to 0. So x equals 1 is extraneous. We actually have no solution. Now, technically, on this problem, I didn't actually need to finish solving. We could have stopped at this step right here. This is a principal square root, and if you remember, principal square roots are always the positive square roots. If we take the square root of a number, we are going to end up with a positive number. It will never be negative. And so at this stage, we could have stopped and just said no solution. We did not need to finish solving. Okay, let's look at a couple more examples. Let's look at example D. D, we have the square root of x plus 5 plus 2 equals 5. First thing I want to do is I want to move anything that is outside my square root to the other side. So I'm going to subtract 2 from both sides. We get the square root of x plus 5 equals 3. Now that our square root is by itself, I can square both sides. On the right, my square root and my square cancel, leaving me with x plus 5. And on the right, we get 3 squared is 9. In order to finish solving, we're going to subtract 5 from both sides. And we get x equals 4. Okay, if we check this, I get the square root of 4 plus 5, replace x with 4, plus 2, I want to know, is this equal to 5? Well, if we simplify inside our square root, we get square root of 9. Square root of 9 is 3. And 3 plus 2 is in fact 5. So x equals 4 is our solution. Alright, so let's go ahead and step up the difficulty level a little bit. Let's look at example E. In the grand scheme of things, I would say this is a medium difficulty level problem. First thing we want to do is isolate our square root. So I'm going to subtract 2 from both sides. That leaves us with the square root of 2x minus 1 equals x minus 2. All right, I want to square both sides. And on the right, you do need to be careful. We can't distribute the square. Remember that we want to FOIL. So instead of putting x minus 2 squared, I'm going to go ahead and write x minus 2 times x minus 2. Okay, on the right, or sorry, on the left, we get our square and our square root cancel, leaving me with 2x minus 1. On the right, if we FOIL firsts, we get x squared. Outsides, we get minus 2x. Insides, we get minus 2x. And lasts, we get plus 4. I'm going to go ahead and simplify. We can combine our like terms. which gives me x squared minus 4x plus 4. Okay, this is a quadratic equation, so in order to solve this, I want to move everything to one side. I'm going to subtract 2x and add 1. That gives me 0 equals x squared minus 6x plus 5. We can now go ahead and factor this. If we factor this, we get x squared is x and x. 5 is 1 and 5. In order to multiply to a positive 5, we have same signs. To combine to a negative 6, that means that they are both negative. Okay, so we go ahead and set each one of these equal to 0. For the first one, I can add 1 to both sides. We get x equals 1. Second one, I can add 5 to both sides. And I get x equals 5. So now we want to go ahead and check it. For the first one, we get the square root of 2 times 1 minus 1 plus 2. Is this equal to 1? If we simplify inside the square root, we get 2 times 1 is 2, minus 1 is the square root of 1. Square root of 1 is 1 plus 2, and 1 plus 2 is equal to 3, which is not the same thing as 1, so I'm going to discard this solution. This is extraneous. But we can't go so far as to say no solution yet. We still have to check 5. So if we plug in 5, we get the square root of 2 times 5 minus 1 plus 2. I want to know, is this equal to 5? So 2 times 5 is 10. Minus 1 is 9. Square root of 9 is 3. And 3 plus 2 is 5. This one does check out. So our solution is x equals 5. And that takes care of solving radical equations.